Today we're going to start our chapter on logarithms, and it's really just going to be an introduction. What exactly is a logarithm? And I'm going to keep referring back to it. A logarithm is just an exponent. It's an exponent written in a different way. So I'm going to start by this equation, 2 to the x power equals 8. And we're going to solve this in two different ways. So the first way is just how we would solve it before we even heard the word logarithm or knew anything about it. And let's go back and do a little review of exponential equations. So I have 2 to the x power, and it equals 8. And right now, the only way I know to solve for x is I would see if I can change that 8 to something with a base of 2. So I would see if I can get those bases to be the same. So now I'm thinking 2 to the third power is also equivalent to 8. And now when the bases are the same, I can set my exponents equal to each other. We did that earlier in the chapter. And now I know x equals 3. So that's one way we can solve this. Something else we can do is if I can't solve for x where it is, I can think about changing the form. And what I mean by that is converting an exponent to a logarithm. It just changes the place where everything is. So what I'm going to do is I'm going to write this same equation as log with a base of 2 and now 8, and it equals x. And these are equivalent. This means the exact same thing. And now I can see that my x will equal 3. We don't know why yet, but I'm going to explain that to you as the lesson goes on, that all of this is going to be equivalent to 3. And that's what we're going to learn today. Okay, so what I just did in that equation is I converted an exponent to a logarithm. So our generic form of an exponent, if we have a base, and then I just have some power up here, and that's going to equal some number. So that problem we had before, we had 2 to the x equals 8. So just a base raised to an exponent equals some number. I'm going to convert that to a logarithmic form, and that's just log and then a base b. It's a subscript. And now I'm going to have the x, so that would be your answer. And log with the x, that's all one line if you were typing. The other reason I'm using printed notes today is you're going to see as we go on how it looks if we type it. And it all is going to equal the y. So it changes the place of where your exponent would be. It's going to help us solve equations. So the first thing we're going to do for this example is we're just going to convert. And we're going to convert 3 to the fourth equals 81. We know that's true. 3 times 3 times 3 times 3 equals 81. If I want to change this to a logarithm, I'm going to say log base 3 of 81 equals 4. If we have a logarithm, we can also write that as an exponent. I'm going to first find my base. In this case, it's a 10. Over here, this is my exponent. And this would be my answer. So it equals 1,000. So this problem is just asking me to convert the forms. It's not asking me to solve anything. It's just asking me to convert the forms back and forth. So here we're going to have some practice problems. It says you try. What I'd like you to do is pause the video and then try them. And then I'm going to work through them and you can check your answers. Okay, so to write these, 7 to the third equals 343. That's log base 7 of 343 equals 3. And then this is a logarithm, to convert it to exponential form, it's 4 squared equals 16. And you could see a little more clearly when it's typed that log 16 and 2, they're all the same font size and all on the same line, and the 4 is a subscript. Now we're going to get into evaluating logarithms. Log base 5 of 125, this is going to be equivalent to a number. First time we do this, I'm going to put equals like a question mark. It gives us something to solve for. You can sometimes see people when you're first starting put an x there, but there's not really a variable because this is not an equation. But what it's saying is 5 to what power equals 125? And then you're figuring out what would that power be. And it's 5 to the third power equals 125. So all of this is equal to a 3. So it's not exactly an x equals 3 or a question mark equals 3. This is equivalent to a 3. Your answer would just be 3. And the same thing for here, for b. You can think of it as, what is all of that going to equal? But I do recommend at the beginning, put something there and convert it to an exponent. So you're saying 1/4 raised to what power is going to give you a 16. So how can we get that? And that would be a -2, because 1/4 to the -2nd power would give you 16. But all of this isn't your answer. The answer is just -2, because all of this is equivalent to a -2. So same as before, I recommend pausing the video, practicing on these 4, and then I'm going to go through, because there's a couple tricky ones I threw in there that I really want you to try on your own before you see me go through them. Okay, so for the first one, we're looking for 3 to what power is going to equal 0. And then there isn't an exponent. There isn't anything we can raise it to that will equal 0, because negative numbers would be reciprocals, and 3 to the 0 power would give us 1, so we call that undefined. So that's just undefined, because it's not possible. And then for this one, here's our base. And so I'm saying 2 to what power, to what power equals 2 to the 8th. So now we have 2 exponents. We have the bases the same, and we can see if that were a variable, we would have x equals 8, but instead all of this just equals 8. Now I'm going to have 3 to some power that we don't know equals 1/81, and that will be the -4th power. And now 7 to what power will give you a -7 power. And that's another one that's just not possible. So it's going to be undefined. So far, all the problems we've done should really be done without your calculator. We haven't even talked about the calculator, but right now, I'd like you to take it out. Either the TI-83s or the TI-84s. If you have a Casio, you're going to have to look online just to figure out where the buttons are, because I'm not exactly sure, but I know they are on there. Your calculator on the main screen has 2 buttons. One of them looks like this. It just says log. And the other one looks like this, and it says LN. And these are the keys we're going to talk about now. The first one is the common logarithm. It's a common logarithm because it's used a lot. It's really, really common. And that's when it has a base of 10. And the base of 10 is used so often, they don't even write it. It's just implied, it's there, and it's not put at all. So what I mean by that, it's what this typed text says. If it has log with a base of 10, and then I'm just going to put an x here, they're never going to write that base of 10. What they're going to write instead is just log x. So if you don't see a base at all, it has a base of 10, and you use this button on the calculator. That's your calculator button. It's just the one that says log. The other one is called the natural log, and that's with your base of e. It's the same e when we had continually compounding interest. It shows up pretty frequently as well. It's called the natural logarithm, and it's when we have a log with a base of e with something like that. But they don't write it like that. It's like an abbreviation. They write L, N, and then and that X could be a number. And that's the ln on your calculator. And that's the natural log. And that's on your calculator. So I don't know why we're starting with B. There's no number A right now. That's just my mistake. So what I'd like you to do on your calculator is, what is the value of the logarithmic function to the nearest tenth of, just type in L, N, E. Try to find that on your calculator. So you're just typing in L, N, and then another E, because that's something that we see a whole lot. And I want you to see if you can get 1. You should get a 1. Remember, ln it's on the left-hand side, and the E, there's a couple different spots you can find it. It's above the division sign if you're having a hard time finding it. Next one I'd like you to try to type in is just the natural log of negative 1.87. We're just making sure we can find that. See what your calculator tells you. If you're getting an error message, that's correct. And we would say that's undefined. And if you think about why, because what this is actually asking us to find, it's a base of e, negative 1.87. So it's saying e to what power would give us a negative number? And as we said in our first examples, there's no exponent. We can't raise that constant to any exponent that's going to result in a negative. And if you think about even how we graphed exponential functions and where the asymptotes were, it's just not going to be possible. So that's the other reason why those would be negative. Also, try some of the common logarithms. Again, it'd be a great idea to pause this. Just try to put them in your calculator. It's just an exercise, and try and use your calculator. See if you can get the correct numbers. I'm going to write them down in a second here to the, I guess it says the 10,000ths place. And I didn't read my own directions, so I'm switching it to the thousandths place. Okay, you will have homework problems, and please let me know if you have any questions.